So thanks again for being here, everyone. This is the fifth in our series of Fun Friday workshops, the first four of which were held in February. This one is being held on February 30th, also known as March 1st this year, a leap year. But thanks very much for being here. My name's Alan Rossman. I teach in the statistics department at Cal Poly in San Luis Obispo, California. I'm very happy to introduce my friend and colleague, Beth Chance, who also teaches in the statistics department at Cal Poly. And Beth has been active in statistics education for quite a while. She's the driving force behind the applet collection that you may have heard of. She's won national teaching awards and written textbooks and developed materials and conducted educational research. And I'll stop there and turn it over to Beth to talk about the Monty Hall problem as a way to introduce students to what you see on the screen. So thanks again for being here. Thanks to Beth. I will mute myself now.
And thanks for coming on so late on a Friday to accommodate the schedules. So if you have been to this series of workshops, remember our main goal is to kind of immerse you in the experience as a student. And so I'll try and do that again today. And this is where this activity often occurs in my class. So sometimes it's even the very first day of class, because I tend to teach 2 days in a regular classroom and 2 days in a lab. And sometimes it just works out that the lab day is maybe the very first day of the quarter. And so I might do a little bit on the syllabus and then either this activity, or now I usually do it later in that same week. So the first day is just a little bit about definitions of observational unit, variable, how a variable is different from a research question. And then I actually do have them turn in a real brief, what you might call an exit ticket, and I'll show you that in a second. And I give them feedback on that, and I hand it back to them the next day, or I grade it in Canvas overnight, and they get feedback the next day. Now the next day would be in the computer lab, and so they're playing with some statistical software or an applet, just looking at different distributions of different variables and learning how to describe those distributions. And then that night they would do a pre-lab, and I would actually go back into the lab again the next day because the day after that ended up being a holiday and I didn't want to miss the lab day. So I was able to ask my university, could, we move that lab day over, and they were able to accommodate me. So this is what happened the most recent time I taught this course. And so this is an example of what that first exit ticket might look like. So as I said, we've defined all these terms, and this is just practicing using those terms in a very informal formative assessment where I just give them some feedback, and then we continue talking about these ideas throughout the quarter. And then this is what that first pre-lab might look like. And I do call it pre-lab 0. To be honest, it really is just practice and submitting these pre-labs, getting used to doing these pre-labs the night before the labs. So then we can kind of hit the ground running when we do start the lab the next day. So this one, they all got a free point for doing it just to get used to that process. But it also introduces them to what we're going to be talking about, which is interpreting rain. And I often hear statements like there's a 20% chance of rain. But if you ask people what that really means or how it's actually determined, most people don't have that understanding. They just kind of take it for granted that they know what that's talking about or how it's calculated. So that's going to be the goal of the lab. So this would be the slide that my students would see as they come into the classroom that day. I've been teaching long enough that I now have a cartoon on every single slide deck, and that it almost always fits the theme of the class that day. So this is one of my all-time favorites because students usually appreciate it, and it totally fits that our goal in this class is to help you understand what randomness does and doesn't look like. And so getting them used to that idea, and that it's a non-trivial idea. And then I might briefly touch on that exit ticket or the previous lab where they were just looking at graphs of variables and some of the things that they should be seeing, and give them an opportunity to ask any follow-up questions that they have based on what they were most recently doing. I might not say too much here because that was a lab the previous day and they have several days before that's actually due. So just making sure that they're progressing well on that lab assignment before we start the next one. And here, I think these ideas are important enough that I might take a few minutes at the beginning of the lab section to make sure that, we're comfortable in thinking about these terms and mean versus standard deviation. And normally I don't have much talking to them time in the lab environment. Partly our lab has this big post in the middle and nobody can see the front of the room. So I try and minimize the talking, but early in the quarter, I might do a teeny bit more. And then I do give them a little bit of motivation. You may have noticed that I was referencing a preliminaries chapter. So we do have this chapter early on, which basically over 3 days, they do these 3 ideas, but really trying to emphasize to them, we're not going in depth on any of these 3 ideas yet, but that these 3 ideas are going to be building blocks for everything we talk about later. And so today we're going to focus on the probability simulation one, and this idea that interpreting is a little bit different from evaluating. And I try and attach those terms to it so I can refer to that throughout the quarter, that when I ask you to interpret something, I don't want you just telling me if it's large or small. I'm going to really be wanting you to tell me what that means or explaining to somebody else what that means. And this idea of simulation and modeling might also be something they're not totally familiar with. And so I do try and again, use that language and how it's going to relate to our study of probability to be able to simulate how often something happens to help us understand randomness. So that would be maybe just the first 5 minutes of that lab class period. And then I'm just going to let them loose with a partner. They will use the same partner they used the day before, so there's not that setup time. But I do ask them either to sit together in certain places, or if they all came in the previous day, I just counted off, and then they would go and join a specific group in Canvas so that they were submitting their assignment together. And so if somebody doesn't show up, sometimes we move those around so that the partner they work with that day is who they're submitting with. And then they're going to work through this online lab. And something we may want to talk about at the end today is different ways of implementing this kind of lab assignment. I'm going to show you again exactly what I did in class, which you may or may not want to do something similar, but so I'll try and highlight, what are kind of the important features of that implementation. And then students are going to have access to either a Word file or a Google Doc. And then I've been even encouraging more. We have one computer per student right now, but I'm even tempted to force even more that they work on the same computer, because nowadays they do a really good job of each joining the same Google Doc, and then they can simultaneously edit. But sometimes, and it depends on the assignment a little bit, that can do a little bit into you do these questions, I'll do these questions, which to me defeats the purpose a little bit of them having to collaborate and argue together. Whereas if I force them to work on one computer, or maybe one's running the applet while the other one's typing into the Google Doc, I think they'll get more out of the experience, but I may need to encourage them to do that. They're also going to learn how to make screen captures today as a way of sharing their output with me. And then me, or hopefully me and a TA, are in the classroom that day. And then we're just wandering around answering questions as they come up. And then again, this was a shortened week, so they're going to have Monday's class to ask questions. And then on Tuesday, the final report will be submitted. And again, just getting them in that habit early on of submitting both names so I can track it back. Or if the Canvas groups didn't work out, I can track it back as well. So with that, I'm going to ask you to follow this link, and maybe I can even copy this link into the chat real quick. And again, I would just say go. There's expected to read through this, to follow these instructions, and be working together with their partner. And I'm only there as a resource to answer their questions. This lab has been around. I've used it for many years. And so some of the things I've learned are, again, getting them in the habit of putting their names on the document. Sometimes when they open the Word file, it doesn't let them edit immediately. Again, this is maybe something in the lab with some of the permissions. So they may have to enable editing. So just warning about that in advance, so that's not bothering them. The Google Docs now you can set up where when they click the link, it tells them they have to make a copy first. So that's a way to give everybody the same link. And then everybody gets their own copy when they are making the copy. And then the one thing that's difficult about this implementation is you really need the lab instructions to be almost identical to the what they're going to find in the document, or make the document something. And now I lost where I was. Just open it again. you know, the other thing I have to repeat a lot early in the quarter is you're going to need both documents open. You're going to need the online pages for content and next steps, and then maybe even minimize what's in the Word file as just where they're saving their answers. There is an advantage to everybody using that same document, so you know exactly where their answers are going to appear instead of you having to do a lot of looking around to find their answers. And there's something to have those being in consistent places from student group to student group. And then also encouraging them to maximize these web pages because there will be some embedded windows, and in the lab they have a very nice screen, and so why not take advantage of that? But for some reason they don't always think to do that. So again, reminding them to put their names early on, giving them the goals, reminding them a lot to go back and forth between the online lab and this thing that they're submitting. So the main goal of what they're submitting here is just record keeping of what they've done. And I do usually grade this whole thing. Sometimes I tell them I'm only grading certain questions. You'll see at the end here, there's an application. Maybe that'll be the focus of my grading. But I find if I only grade the application, that's often what they just jump to do, which is going to be very difficult for them if they haven't done the preceding questions. So I do feel there's some reason to have some incentive for doing those preceding questions. And so one of the things that you'll see on the website that Alan shared is a real skeleton of the grading rubric. But I found that, again, after I've done this a few times, I can grade these answers, especially, you know, when they have that common structure, fairly quickly. So I often have 2 sections of 35 students, and probably in a couple hours, I can get through what I want to on giving them the feedback that I want to on that. So if you haven't yet, I kind of like how it says, okay, we're beginning. You'll also notice, you know, kind of a table of contents over here so they can jump back and forth with a little bit of formatting so they know which page they're on, things like that, just make it easier to refer to different things. I don't currently show a video of the game itself. It has varied on how familiar students are with the game. I think you probably could find a video of the recent one. I don't think the revised one necessarily did this particular game where he shows them 3 doors. The contestant picks one, and then the deal is he shows them one of the other doors. They're allowed to switch to the one they hadn't picked or stay with their original door. There was a period of time where I didn't use this as much because there's a movie called 21 that kind of goes through the logic of it. And so students were more familiar with that, but that one's old enough now that usually they've kind of heard of it, but they don't necessarily know or understand the logic behind the answer. And so again, I might encourage them to kind of predict what they think first, just so that it's more powerful when they realize that their prediction was wrong. And so that's something you can do as well. But again, I've maybe streamlined this a little bit depending on what I think will fit most in that 50-minute time period. And I don't expect them to totally finish it in that 50 minutes, but to at least get through probably the first 5 pages together in class. I definitely like them getting to the computer part in class, and then they maybe finish up answering the questions outside of class. That is another thing that I like with the Word file is, you know, they may want to skip ahead for the screen capture part, the really intensive computer part, and then come back and answer some of the questions later. But it's hard to get them to not go in order. So that's not necessarily a bad thing. And again, I didn't design these web pages, but they had enough of a clean look to students that I felt they stayed a little bit more engaged than just giving them a straight Word file. So then I do like giving them the opportunity to play the game a little bit. And so here's an applet. You'll see lots of versions of this applet online. So again, we can talk about pros and cons of some different variations, but I think they all work pretty well. So if I say play, I get to click on a door, and then it gives me the option to stay with that initial one, door 1, or I could switch over to door 2 after the host has shown me a door that doesn't have a winning prize. So we're assuming you don't want to win the goat. In this case, I stay, and it tells me that I would have ended up with a goat rather than the race car, which we're assuming was the more attractive prize. And then I can play again. This is just getting them used to what the game's about, what their options are, and seeing if they can ever win. This idea that it really doesn't matter which door you start with, right? And so they can mix that up, see if that makes a difference. And then there's some feedback on whether they think they won or not. So again, this is hopefully giving them the instructions right there. So it's very well integrated and not taking a lot of cognitive load for them to be doing this. They can also open the applet up in a separate window if that might fit easier on their computer screens and they're more comfortable with toggling back and forth. So then they're supposed to play 10 times with the stay strategy. So I'm going to ask you to do that. So go ahead and just play 10 times, keep track of how many times in those 10 that you win. And then when you're ready, I'll have you go ahead and put your number of wins in those 10 plays in the chat. And so if you're having any questions getting to the applet or what the applet's doing, let us know. But for now, I want you to just try and play 10 times and then report in the chat how many times you won in those 10. And please use the stay strategy the whole time. Maybe I haven't even introduced you to the switch strategy yet. And you'll notice this is what they could be doing in the form. They would just be saying whether they got the car or goat or whether they won or lost. And then here I have them predict. I try and label it, B, this is something that they need to do and determine that percentage. Here's often where I might say, what's the difference between a proportion or a percentage or the number of wins, and making sure they can do that. And then I put little red arrows by things generally where I want them to answer, where they're going to be graded. And I even try and sometimes make it so, the formatting's a little bit different. So that stands out to them. And then just thinking about this idea, which you're seeing in the chat, of whether everybody obtains the same result or not. What I'm going to show you now is actually something I don't do anymore. And so I'll show you this lab sheet in the slides, but I just put this together ahead of time in Excel. And I'm just going to start typing in the things I'm seeing in the chat. So somebody maybe won 3 times out of 10. And so it's going to compute the proportions, so 3 out of 10. This is the total number of wins so far. And this is going to be the cumulative proportion. And then another one I just saw was 2. And so now that individual student had a proportion of 0.2, but now that's 5 wins out of 20 because everybody played exactly 10 times. And so now that's going to be 5 out of 20. And then some other numbers that I'm seeing is I could just build this up based on the student's results. So maybe we go around the room and they'd be sharing what they got as they played the game. And I would just kind of build this up. And I'll tell you in a little bit why I don't use this anymore. It does take, I think, a while for students to really understand what's going on here. But why I might do it is this kind of idea of crowdsourcing and seeing their own data, but also starting this investigation, kind of slowly, really trying to build it up in pieces. I'll wait to see if I get 2 more new ones in the chat, so I'm not cheating too much. But one thing I like about this particular approach is, again, I haven't done a lot of cognitive load on the students, but maybe it's a little too much of a demo. But what I want them to focus on is what I mean by this cumulative proportion, or well, I used to call it the cumulative relative frequency, but that was starting to get too many long words. So cumulative proportion is a little bit different. Ooh, a 0. And then we get to joke with them. Maybe don't go play the lottery today. It's just not your lucky day. And just seeing how this number does seem to be settling down a little bit, not changing as much as we do more and more of these sets of 10. And something you can come back to later is this cumulative number of wins actually maybe isn't settling down as much, that it really is the proportion we want to focus on, not the number of wins. And so we can get that idea across. And again, this is something we would do maybe in a more common lab environment where I'm leading the activity a little bit more. What they're doing in the more standalone lab is just kind of recording their 10. And then they're going to have the complete computer play different sets of 10. So if I scroll down a little bit, you can see I've selected the stay strategy. I'm going to do it 10 more times and I'm just going to press go. And you can watch the animation go by. Again, just trying to make sure they've understand that process a little bit. Or we're going to do 10 at a time. So maybe click off the animation, it goes a little bit faster. But after each 10, I might ask them to record what they got for those number of wins and the percentage of wins, which is being reported by the applet. And they're going to do this up to a total of 100, say, total plays of the game. One more. So I did a few, right? So multiples of 10, and this, again, keeping track of that percentage to see how that percentage bounces around a little bit because it's random, but maybe starts to get a little bit more like something I could predict. So thinking about, this number's not changing so much anymore. So then I might have them do 100 at a time. And really just thinking about that idea of, when have you done it enough? When is that number really not changing that you think you get a pretty good idea of what that number is going to be if you keep doing this over and over again. So I'm going to go up to 1,000. And again, I wouldn't probably be demoing this part. This is something I want students doing on their own. And again, maybe keeping track and seeing how that number is changing. And so asking them to notice, how that percentage is changing. And this is the kind of question where, and I may have this conversation with them. There's not necessarily a wrong answer here. I just want to tell what you're noticing. And when I grade it, I might give them some feedback on, maybe notice this if you haven't yet. But, this is just keeping track that they've been doing it more than there's a right or a wrong answer. Any questions so far? Anybody want to call me over to their group and ask any questions? All right. So then maybe we're ready for next. And now I'm going to give them a definition. So again, trying to make that stand out. Here's what, kind of the goal of this activity is to understand this definition. And then thinking about how that applies to what they just did. And again, with some reminders about, I want decimals between 0 and 1. I find it sometimes helpful to break them of that habit of thinking of probabilities in terms of percentages, because that's going to be easier down the road. And then maybe they don't think they have a good estimate of the probability yet. So what might they do in the simulation to obtain a better estimate? So again, this is something I'm hoping they're talking back and forth with their partner before they type something in here, right? So then just kind of going back and forth. As I said earlier, it's really helpful to make these as consistent as possible and then give them some reminders to go back to the online instructions after they've done a few of those in a row. So then we're going to do the computer simulation a little, well, actually, no, we're not yet. So the probability of a win turns out to be 1/3. So that's something else I've kind of gone back and forth with a bit of how much to expect them to figure out why it's 1/3. Right now, I'm just going to tell them it's 1/3, but maybe they'll have seen that's what that number was starting to converge to. And then I even tell them now, instead of that prediction, I say a lot of people think it's 0.5 because I don't want them to feel bad if they have that prediction. That's a very common prediction because once he's shown me a door, there's 2 doors left. So there's a 50-50 chance that one of them has the car and one of them has the other goat. So let's investigate that. So we're going to return to the applet. So I like how that's kind of all embedded here. The one thing that's not as optimal here is it's kind of gotten rid of their earlier results. So I might even ask them to, replicate that a little bit without the animation just to have that reference point. But then what I'm going to have them do is move to the switch strategy. And again, maybe run it 1,000 times. First unchecking the animation box so it goes a little bit faster. And then I do find it helpful to give them kind of screen captures that hopefully match what they're seeing in the applet and to just try and make sure they're doing the right thing here. And then now I'm going to press go. And you'll notice here there's a link to a separate web page, a resource just telling them how to make screen captures. And because this is something I'm going to want them to put into their report. And a skill that they're going to need throughout the course. And so I really try and get that down and try and give them both Mac and PC instructions because those are a little bit different. I'm trying to make that as easy as possible. And then hopefully question J, they'll start to notice that it's clear pretty quickly that the switch strategy does have a higher percentage of wins in the long run compared to the stay strategy. And it turns out to be 2/3 mathematically. And so they can see how we're getting close to that as we run the simulation long enough. So really wanting them to practice that interpretation. Again, it can link back. That's what's nice about the online labs, just links back to that earlier definition if they want a refresher on that. As I said before, this reminder interpretation. Now, why am I putting this in the lab? You saw it on the slides. I told them what I meant by interpretation. Anything I put in the slides and say out loud at the beginning of the lab was really for my benefit only. It's in writing. Students who weren't in lab that day will see it, but I cannot tell you how many times that a student will, if I didn't put it here, will say, what did you mean by interpretation? So I would just repeat it. Doesn't hurt to repeat it. I wouldn't assume they heard anything I said at the beginning of the lab period. So they're not just telling me if it's large or small, just this idea of, well, if I run it long enough, just talking about what they just did, if I run it long enough, that percentage of wins is getting closer to 66.7%, or that proportion is getting closer and closer to 2/3 in the long run. All right. And again, that's something that they're putting in their instructions, including their screen capture. Again, lots of reminders to do that. And that's it as far as the simulation of what I want them to be able to have done with that applet. So that gets us to the application part. Again, a reminder of that definition, and then a breakdown of, I'm going to ask you to make these interpretations, and these are the kinds of things I want you to look for in that interpretation. So identifying what is this random process, and again, that's a new term for them, but just thinking about what is being done over and over again, and what are the identical conditions. So in the Monty Hall problem, that's like picking a door at random, and how the cars were set up, the cars and goats were set up behind the doors to begin with, is completely at random. It doesn't matter which door the host shows you, there's no kind of hidden biases here. We're thinking of those identical conditions. And then what proportion is being calculated? So for example, the proportion of wins. Something else that I've learned over the years is telling them explicitly that if I'm asking them to interpret probability, they should not use the word probability or any of its synonyms. So I don't want them to say, well, it's the chance of winning or the odds of winning or the likelihood of winning. That I really want that long run proportion, that proportion of times, but telling me what you mean by of times. So this idea of repeating this process over and over again. So probability of getting a red M&M is fairly easy for them. And again, this is something I'll give them lots of help if they come and ask me during the lab period or between the lab periods. A little bit harder is this idea of probability of winning at a daily lottery game, partly because I guess I give them the hint now, right? They would just say that proportion means if I play 1,000 times, I expect to win 1 out of 1,000. If you put the word expect there, or on average, that's not so bad. But I would much rather they turn this into that decimal and talk about that fraction of times or that proportion of times if I play it forever. So I'm trying to get them in the habit of never giving me that denominator, always just talking about playing it forever. And those skills, I think, are helpful when you get to something like number 3, which is much, much harder for them, especially this idea of identical conditions. So really thinking about, what do I think about being repeated over and over again? And usually they can kind of get to repeating tomorrow. And so then I'll prod them to, well, what do you mean about repeating tomorrow? And so this idea of, well, under identical conditions, if I had days like tomorrow, meaning the same forecast, the same temperature, the same rain conditions likelihood, the same humidity, the same dew point, right? Whatever that is, if that's identical. And in this case, it's probably based on historical records. So they're looking at thousands of days in history that had these essential conditions. If they were the same, maybe in the past it did rain on 30% of those. And so that allows me to say, in the long run, of 30% of days like this, I think it's going to rain roughly 0.3 as that proportion of times. So trying to get them to use that word proportion, even chance. So I try and word these a little bit differently so they get that idea of, no matter how I ask you, to interpret that, I want them thinking about probability. And then these are not, 4 is not too hard. So turning it into a probability statement, and then 5, turning it into this idea of repeated random samples. That's something that we're going to use a lot later in the course that they struggle with. And so really trying to get them used to that early on in the course, or practice with that, again, where they'll have an opportunity for feedback. So again, this may be the main thing I focus my grading on, or a little bit more, but giving them that practice. And then one thing I also like about these online labs is giving them that very consistent look and feel each time. Usually there's a link at the bottom here where they can go back to previous labs, things like that, but reminding them, this is what you were supposed to learn in this assignment. These are the key takeaways or what you need to follow up with if you're not as comfortable with it. And again, putting names on it. Always lots of reminders about that. All right. So that's actually, this is just what I said. These are the Excel formulas I put in if you wanted to try something like that. But I actually don't use this as much anymore because I found it was maybe a different, maybe not worth the time. Did take a lot more time, and especially turning this into a more standalone lab where we're not all together or getting to this part at the same time of the lab activity. And then I end the lab just saying, again, remember, we're not meeting again till Monday, when things are due, and just trying to motivate that they learn 3 kind of very different things this week. And we'll finally start to see, because we're going to actually do statistical inference in the next class period. So putting this all together. And then the quiz Monday night, if you can read it, here's what's going on in that quiz, where it may be a question about the syllabus to make sure they've read that. Some more practice with defining variables and observational unit. And then here's a 3-point question out of 10 on that interpretation of probability. So again, this is due after class, so we've had a little bit more time to talk about it, and then a little bit of a more straightforward context. And then this is that Bob and Tim example that you may have heard us refer to. This is one version. There's another version where I reverse the order of the pictures, or reverse the order of whether I ask about Bob or Tim or Bob, letting them know that's a free point, and then we'll analyze that question later that week in terms of statistical inference. So I'll stop there. There's a few different things we could talk about if you wanted. As I mentioned, there is a movie 21 that you could have students watch before or after. This is the Excel sheet we did talk about. This is, I did this activity with 5th graders where I set up, this is actually a coat hanger on some little styrofoam pads. These are clothespins that went to 3 index cards. And on the back of one of the 3 index cards was a free coupon for pizza. And so that's what they got if they won. And so I made them play the game a few times just to understand it. And then I had them use the applet to play it longer to try and understand probability. And then I used to do a lot more with asking them to explain why it comes out to be 1/3 and 2/3. But again, that was difficult for students. And so now I just use it a little bit more to understand, that simulation and probability. Other applets allow you to change the number of doors. That might be another good extension to see how that influences that probabilities, and why it starts to make more sense on how the host knowing which door to choose is a key piece of information in this activity, and why it changes those probabilities. And then I do sometimes use a different context, which is called Random Babies, which has an applet with it. Again, trying to make that applet represent that process as visually as possible. And so this is returning babies to their homes at random, and then again, keeping track of that relative frequency in a way that lets you play the game a large number of times and see how that relative frequency tends to average out. And they can try it for different numbers of wins and things like that. This one's nice because they have to think about why 3 matches can't occur. It's also nice because you can do that card simulation. You can do a tactile simulation where students get a set of 4 cards and they play with each other, where they randomly deal them out and kind of keep track of how many numbers of matches they get. And then this is nice if you do have a class that does do a little bit more with probability, is they can do the exact probability calculation. And because there's only 24 possible ways to do this. And so you can actually list out all 24 and then think about exactly how many, get that exact calculation. And then a follow-up context might be, before people got in an elevator, they drop their cell phones, think about the probability they all pick up the right cell phone. And then a little bit more about the applet if you wanted, or a little bit more about the online format. So any questions on that? The numbers, yeah, that was another TV show that had a nice episode on Monty Hall, which you can probably search on to find. Thanks, Roger.
Questions, comments, reactions, other thoughts about introducing students to what probability means, what randomness means?
Oh, my
Feel free
students.
to put something in the chat or unmute.
So this is Kate.
Okay,
How you doing, Beth?
good. How are you?
Good. Do you have them do do you introduce conditional probabilities and have them calculated, or do you?
Not here. I have sometimes done this when I was trying to get them to really understand where the 1/3 and 2/3 are coming from, have them kind of set up a little table and think about, where things can happen or not happen. But that wasn't always very helpful either. I found this just logic of thinking about, what's the one way you can win if you do stay? What happens if you switch? And he shows you a goat, then the only way you lose if you had picked the right door to begin with. And they can usually kind of go through this and then maybe even talk about complement a little bit. But at this point, I'm probably not doing it in terms of a conditional probability, but that might come later in the course. So I tend to teach probability kind of as I need it or just in time, rather than doing a whole section of probability at the beginning of the course. And so, yeah, as I said, this first week, I'm just spending this one day just trying to get them to use that, that language a little bit more precisely.
Cool, thanks.
Hi, this is Rick Powers. I have a question. Do you have students that struggle with accessing Google Documents, or are they pretty comfortable with that process?
They're pretty comfortable more and more, but I do give them both either the Word file or the Google Docs. I don't know that anybody uses the Word files anymore. And they're pretty comfortable with sharing and adding their partner. So I don't even explain how to do that anymore because they know more than I do.
Yeah. Okay, thanks.
And then my course management system used to have more trouble when they uploaded files, and so I would restrict that to a Word file or a PDF, but it's actually a little bit better now. It still probably can't do pages, so I do try, especially the Mac users, sometimes we have a little bit more trouble sharing documents, but usually they can convert it to a PDF and then I can write right on it when I grade it. We found the numbers episode. Thank you.
Beth, this is Adam Scharfenberger. Question for you. I like how you use this to start the probability unit. Do you find I guess my concern would be, and I want to know your opinion on it, that is it for some students, would it be more beneficial to almost do this kind of activity with a coin where they intuitively know it's 50%, but then show that long-term average happening? And I guess I just asked that, do they have trouble putting together all that information on the applet, et cetera, or can they work through that to figure out what's going on?
Yeah, I find the coin tossing, I like this one because there is that surprise element or that
Yeah.
counterintuitive element. And it gets their attention and makes them pay attention and makes them realize they've got some things to learn or why the simulations are so useful. But you're right, when we do come back to this the next week and we're getting into statistical inference, we do start with that coin tossing model where they are more familiar with it. So yeah, I like making this something they have to think a little bit more about first.
Great. Thanks. I like it. I think I'm going to dive in with this problem then. I just wanted to hear your opinion on that.
Yeah, I thought you were going to go more about, the game's too old, or I mean, this one's not really a gambling question, but I do try and not make it sound too much like probability is all about gambling. And
Yeah.
that is one reason why maybe I use this sometimes over the random babies, because that literally does start with, suppose, babies are returned to their mothers at a hospital at random. And I do think some students feel uncomfortable with that context, whereas this one they seem to have enough familiarity with that it gets them engaged.
Thank you.
And kind of it's nice that they don't know the answer. Yeah.
More questions, comments, reactions, ideas? You may have noticed I did paste in the chat the link to the evaluation form, not just for Beth's session today, but for the series of workshops over the past 5 Fridays. So if you could take a few minutes and fill that out, that would be much appreciated. Doesn't have to be this minute, but at some point in the next week, if you could, that would be great. More comments, questions, reactions? I know for those of you in the eastern part of the country, it's pretty much the weekend. Might even be your spring break.
Yeah, the birthday problem's another good one. And kind of back to Adam's question, I mean, it is a lot managing the online document with the applet, with the Word file, and you saw with the pre-lab. So I really do try and make the initial assignments as much about just getting used to that process and then trying to be as consistent as possible with that process. So it's not distracting away from, let's learn about probability. One of my real quick, one of my favorite ones actually I got from Roger was, what's the probability of getting consecutive numbers in say a 5-pick lottery? Because that is one where it's very hard for them to know where to start, whereas a simulation can be very helpful. Is that you, Kate?
Yeah, that was me again. Sorry. I was just gonna say that I used to, until this semester, I used to always have my students, each one at their own computer, still in a group, and I found that they all just kind of worked by themselves. This semester, I have whiteboards all over the room and pods of tables, and then their computers are off to the side, and they're now on a computer, all looking at what each other's doing and then writing on the whiteboard. So I find that it's so much better than it used to be. I want to find a way to do that in my online classes, and I haven't figured that one out yet.
Yeah, I tried during COVID to send them into breakout rooms and then to call me in when they had a question. So that wasn't great. And so sometimes now in the classroom, when somebody calls me over, I think what I need to do more of is, well, what did your partner think? Just to make sure they are doing that discussion. Yeah.
My problem is that mine are asynchronous online classes, so that they just work on their own. And I still see the, I'll do problem 1, you do problem 2 kind of mentality. Thanks a lot.
Yeah, a great question about an applet for the birthday problem. I don't know of one. There probably is. The one at Stanford, probably surprise might have it, but Alan, I know you've done that activity a lot more than I have, because you just
Don't
collect
know
the
if I
data,
do.
right?
Yeah.
You want to say a bit more about how you do it?
Well, I just do the usual thing of go around the room and see if 2 people have the same birthday. I just ask for January birthday people to raise their hands, and then we compare the dates, and then we go to February and compare the dates, and so on and so on. My classes are typically 35 to 50 students, which means there's an 80% or so probability of at least 2 people matching the same birthday.
And do you follow up with Johnny Carson?
Yeah, I really like to follow up by saying how many people match, let's say, this particular birthday. and to get them to realize it's much, much, much less likely that somebody is going to match a particular birthday than it is that at least 2 people in the room will match with each other.
And I think that clip is still around of a Johnny Carson episode where he did that and then thought that the expert didn't know what they were talking about. But most students don't know who Johnny Carson is anymore. Yeah.
Well, it's 5 till the hour. We could certainly finish 5 minutes early here if there are no more questions or comments. But if you have some, feel free. We found a birthday problem applet or something, it looks like. Thank you for that. Please do take a few minutes, either right now while it's on your mind, or sometime next week to fill out the evaluation form, if you wouldn't mind. Let me also say that in the end of April, the last 2 Fridays of April, we're going to have a dozen or more people, participants, who have tried out at least one of these activities with their own students come and do a panel discussion that we'll have on Zoom, and we'll invite all of you to attend and hear a panel of teachers who have tried to implement one of these activities with their own students, talk about what worked well, what they learned from the experience, and things like that. And of course, I'll be sending out email messages before that to let you know, but that'll be the last 2 Fridays of April. In fact, some of the folks on the meeting here might be working with Beth to implement this Monty Hall problem. If you want to stick around for a couple minutes and chat with Beth, that'd be great if you're available. Okay, well, thank you very much for coming today. Thanks for everyone who's come over the past 5 weeks here. Have a good weekend, and I hope we'll stay in touch and see you at future workshops.